Hi, and welcome to our technical deep dive on XMPro stream hosts and collections. In this video, we'll explore how these powerful tools enable scalable real-time data processing. Whether you're managing a few assets or thousands, stream hosts and collections provide the flexibility, efficiency, and scalability needed to handle complex data orchestration tasks. Let's get started and see how XMPro can transform your data operations.
When building intelligent business operations solutions, it's easy to focus solely on the user interface. However, this overlooks the crucial components that power and drive the solution behind the scenes. Data streams, stream hosts, and collections are the hidden yet essential elements of XMPro, ensuring your intelligent operations solutions are robust and scalable. The Data Stream Designer is a canvas where we map out real-time data flows for specific use cases. It allows users to integrate, transform, orchestrate, and sanitize data within a single cohesive data workflow. With over 100 integrations, 75 plus analytics agents, and 60 plus action agents, it empowers you to derive meaningful insights, predict future trends, and automate responses seamlessly. Underpinning our data streams are stream hosts, which are responsible for executing the logic of the data streams configured in the Data Stream Designer. When you configure a data stream and hit publish, a stream host takes over to run it. The number and location of stream hosts depend on your use case. For centralized operations, you might use a single stream host. For localized operations, stream hosts can be deployed as close to assets as required, ensuring real-time data processing right where it's needed. Stream hosts run the data streams designed in the Data Stream Designer, executing the logic and processes you have configured. They enable the agent library to communicate with various entities, including assets, line of business applications, and other systems. Let's jump into an example to consider the scalability of stream hosts. Imagine you're monitoring the temperature of an asset. The data stream collects temperature data, filters for values above a certain threshold, and then creates a work order in, for example, SAP. At the bottom, we have one asset with compute capability next to it, and we have a stream host deployed on it. This computing capability could be a Windows server or a Linux-based system. There are multiple options available to us here. Currently, this stream host is running for only one asset, but what happens when we have multiple assets? This is where collections come in. A collection is a container that enables a grouping of stream hosts running the same use cases. A collection allows us to deploy one data stream to multiple stream hosts running the same use case automatically. By doing this, a single data stream can be published to one collection and the stream hosts by self-subscribing to the collection, download, and then run the data stream logic. Next, let's touch on collection variables. Collection variables are common to all stream hosts that subscribe to a collection. Each stream host defines a value for these variables locally. This setup enables the same data stream to be deployed to different stream hosts, but the connection details it requires can be unique per stream host. For example, if you have a data stream that requires specific configuration settings, such as IP addresses, port numbers, or authentication credentials, collection variables allow each stream host to use its own local values for these settings. This means that while the logic of the data stream remains consistent across all stream hosts, the specific interactions and connections can be tailored to the unique requirements of each stream host. Now that we have discussed the various aspects of stream hosts and collections, let's conclude with a few examples of how this is deployed in practice. In this example, you'd have multiple assets communicating with a single stream host, which then drives the actions. Various assets can send data to a central OBC server, which can be intercepted and managed by a single stream host. This setup works well for centralized data management and action execution. Alternatively, you can create a different topology where each plant has its own stream host. These individual stream hosts can send data to a central cloud-based stream host, which further processes and integrates the information. This decentralized approach allows for localized data processing and better management of specific plant operations. You can also have a configuration where each stream host runs different data streams, such as OPC, MQT, or others, and sends the processed data to a central area. This setup ensures that each data stream is managed efficiently according to its specific protocol and requirements. Finally, there's an option to run one stream host per asset, assuming you have sufficient compute capability next to each asset. When it comes to scalability, these different topologies, whether running stream hosts next to assets, using a historian, or leveraging cloud-based servers, allow you to optimize data processing according to your operational needs. You can even have distributed streams where parts of a data stream run on different stream hosts, though this requires careful consideration of latency and other factors. Now, let's conclude by addressing some frequently asked questions. If you have any more questions, please reach out to the XMPro team, and one of our solution engineers would be happy to assist you.